I'll talk to you about the journey that we took from doing kind of the old way of doing an operational data store, which is what an ODS stands for. And Karen's going to talk to you about how we utilize Mongo Stitch in that new ODS. A little background about Acxiom. Acxiom specializes in making some sense out of our clients' data. We enable data for multiple uses and solutions. We've been a leader in the identity and ethical data use for 48 years. Acxiom provides data foundations for most of the world's top marketers. Today's learning objectives, we're going to talk about the journey that we did from RDBMs to using a document store in our solution. We will reveal kind of how we did it in the past, how we came to the decision of taking the green pill versus the red pill, to some of the pain points and separation anxiety we had, especially from IT and delivery as we went on from there, and to kind of our full enlightenment, speed, flexibility without the brittleness. So I'm going to go over the business problem that we're trying to solve. We manage the marketing data for our clients. We start with ingesting their data, typically by files from various systems. We map those files into a warehouse, into standard models and interfaces by industry. We load that data into our warehouse. From the warehouse, we create specialized marts. Each mart is a set of tables that is built for a primary usage need. The most common would be enabling campaign tools. So we partner with 3 major campaign providers. We don't try to write the campaign tools, we enable them on our system. And creating reporting marts. So letting Burst and Tableau connect into our systems and report. Another common mart is enabling the client's data for API access. So we take a subsection of their warehouse or their marts and pull it into a real-time system that they can have API access to. This is what our team works on, is this operational data store. One of the major problem points is how do we support multiple clients on this operational data store? How do we customize it per client? So how one client might have a few extra attributes, the other client doesn't. And how can we do this all in a standard way, a repeatable way with the same APIs? So I'm going to talk about how we did in the past and how Mongo technology is allowing us to modernize our system. Our traditional approach would be to load up a database that's for real-time data. This is an example of maybe a loyalty schema that we would put up in the system. You'll notice that we have an extension table here, so we do have flexibility. This is how we would do it in an Oracle system, is the same key with extra attributes, adding that. Next thing we would do is put probably a Node.js system up that would boom. I was saying I don't have a live demo, so how can something go wrong? But I took the wrong pill.
What was your database, Oracle?
Yes. Yeah. Okay. Use a clicker.
Sorry, where do you put the data warehouse?
The data warehouse today is Oracle-based. It's migrating towards,
That's also
yeah, it's migrating towards more of a Hadoop base. So The next step that we would traditionally do is create an API layer, usually in Node.js is what we're doing ours today. That layer would have to translate the schema into JSON, would also have to handle the custom extensions. And then the next thing is enabling our firewall connectivity to that. But then, to get this thing to deploy, we have to say, hey, IT, would you deploy our database, our system? Would you deploy our nodes? Would you deploy our firewall? Oh, shit. And then the second client comes. Then we have to design a new extension table if they have different attributes, make sure that goes through the system correctly, and open another set of tools, tickets. And then you start multiplying that by the third, the fourth. How can we make money if we're having to have so many people involved in deployment? How can we support this if we are, every implementation's a little bit different, and how can we grow this? So let's start talking about how we transitioned to the newer technology. The first step was looking, because I've done this 3 or 4 other times in my past history, so looking at the current solutions and figuring out their access patterns. How are they using the system? So you recall that we take on files and standardize those and pull them into the warehouse. For example, we could take on files from loyalty, offers, accounts, purchases. We could standardize those, get them into the warehouse. But what happens if one of those files has the same kind of key section as another file? So for here, we may have 2 loyalty systems from a large account, and they may use a sequence ID. Well, then they're going to conflict. So how did we solve that? Well, you add another field. So we added a source provider, and the source provider tells me which system it came from, and then it tells me their key. And we call this in our system kind of the natural key. It's the key of their system. Why do I talk about natural key, and why do I bring this up? Because this is the main access pattern we have, is they will have a key, and they're going to ask for data from us. So this is one of the major access patterns that we have. Basically, they have the key, we have the data, they make the call. The PII pattern is where we take in name, address, email, and phone possibility. We take in client files that have the PII information in it. But how I need to identify who those individuals are on the PII. So are these 2 records the same individual or different individuals? They're at different addresses. Well, Acxiom has a unique identity graph that I can send this information through and get a canonical ID out. And that system can say the first, no, it's going too fast, that these are the same people. This is my wife and her married name at our address, and my wife and her maiden name at our address. So Acxiom has this canonical graph database that, given PII, it's only going to hand out a canonical ID. It has all the linkages to know that historically there was a marriage certificate, that Amber Jones and Amber Carter are the same. It's a homegrown. It's our bread and butter. It's the major system that allowed Acxiom to actually go online, because we're not doing string matching, we're doing knowledge-based matching. So this is one of our major patterns that we utilize this graph in all of our systems. We've centralized the capability of converting PII into a canonical ID. So in our warehouse, we can actually store that canonical ID and use the system in real time to convert. So we add this canonical ID to almost every system and into our warehouse. Acxiom calls this consumer link. When you see some of our document models, you'll see consumer link, but it's just our canonical ID. So let's give an example of those two usage patterns in real life, how they're used. Acxiom, our clients will send out email marketing. They'll send out an email with embedded links. When a client clicks on that link will contain probably the hard key in it. That will come over to our system. We will look up the data. We can return the data based off that hard key. Typically, that's going through a microsite where they're clicking on the link, they're going to the microsite, that site calls us, gets the data, and we return that offer to them. So the PII lookup, our clients have systems that either already have PII on them or they're collecting it like on a website. They've collected name, address, email, or phone, any combination of that. Once they submit that, it comes over to our API system, and then it calls out to our graph database, gets canonical ID, and then we look up the data based off of the ID. So we have the PII lookup and we have the hard key lookup. So having those two types of lookups, here's what our collection could look like. The natural key, which is our hard key, is kind of the primary key of our collection. And you'll realize it's a compound key so that we don't have key clashes between their systems. And then our consumer link, which is our canonical ID, it's actually an array. We allow you to associate multiple individuals for one source. So my wife and I could be on the same loyalty record there. Now, do I care about anything else besides these fields in the document? Not really. The joy of a document store, I don't care what else they put in this document, as long as this key section is the same every time, then my APIs will work. So here's an example of our full loyalty. I collapsed the key, but we've got consumer information that talks about points, when's the last award you did, all of that type of information. And this is our standard layout for loyalty, but any client implementation can add extra attributes. So here's our contact history or offers. So our keys, consumers, all of that information is in there. So we don't have to worry about that. So with the identification of our usage patterns, we created basically two APIs to fulfill these patterns. A hard key lookup that uses that natural key, a PII lookup that looks up data from the consumer links point of view, the canonical ID. Now you'll notice because of a document store, you can have different types, and I showed you that loyalty versus contact history versus X. We added a type field into our collection and our key structure. So the client and the API can not only give us either the hard key or the PII, but they can also list the types of documents they want returned, and the API will return, just basically do a filter on this document, this collection, does basically a hard key look, and are you in one of these collections, and returns the data. The great thing about Mongo being a JSON document store is the API doesn't have to do any conversion of what is returned. So we can just read this and return the information. So I'll go into a little bit of how we picked Mongo. 3 years ago, we were restructuring our marketing database solution, the overall solution, into our UDL, Universal Data Layer. So we picked Mongo as a metadata store because we wanted to go away from a relational database for metadata to a document store. This simplified our metadata completely. When we store like a layout of a file, it's one document. It's not 5, 7 intersection tables for that. This made our focus on the administration a lot simpler so we could focus actually on the business logic of the administration. Last year, a group of us came to Mongo World here, or in Chicago, and we saw a presentation on Atlas, and I'm going, okay, I hadn't really known about their cloud offering. And then we saw a presentation on Stitch. So, by the way, they didn't gripe about me putting Stitch in this presentation. So Karen and I, the next week, decided to do a POC. So Karen worked on the Stitch API. I worked on loading data into Atlas. And in 1 week, we were able to go from a hello world to returning collections, to writing collections, to connecting to our canonical ID system back at Acxiom, a call out to convert PII to that, and integrating into our security store. All in 1 week, up and running, great. And then about 2 or 3 weeks later, we got a new contract on the big offering that needed an ODS, and we said, let's do that. Let's redirect to that. We had some backup plans for Stitch just in case because it was beta. Didn't have to use any of those backup plans at all. So I'm going to hand this over to Karen. And Karen's going to talk about how we utilize Stitch in the system. She's been the rock star as far as utilizing Stitch for our company. Some days it's been a little rough and a little bit of a beast, but most days she's been riding the wave and getting shit done. So here's Karen Wilson.
Thank you very much, Scott. I know Scott didn't mean to say that I was a beast, just maybe the implementation. So we're going to go through, as Scott said, we'll talk a little bit about what we've always done and how we kind of did that differently with Stitch. So in the past, as a developer, you get a request for a new project, and so then what do you do when you're starting a new project? Well, you need somewhere to develop that project. So then you have to make a phone call to a guy and say, hey, I need a dev server so that I can do my development on it, right? That's great. I wrote my development, but I don't have any data. So then I got to call another guy and say, hey, can I have a database to put data on? Because I need somewhere to put data. This is not a very good application. Then I have to call a third guy and say, hey, I have data and I have an application, but they can't actually talk to each other. So can you do some work on the firewall and let these machines talk to each other? Great, now I have a system. It's got software, it's got data, it can talk to each other. Now I need somewhere to build and deploy my code, right? So now I've got to make a phone call to another guy that says, hey, can you put a build together? Can you deploy my code to this machine so that someone besides me can actually utilize this, right? And at this point, I've not actually even written any code. I've just set up machines and made phone calls. And this process can take, what, weeks, if you're lucky, right? And then you need a dev server and a test server and an integration server and a production server. And then you need backups for all of those, right? Because you can't just have one system because what if it goes down? So you need failovers. So you've got to do that times 2 or 3 for all of those environments. So this is what our normal project setup looks like. And that is with no development whatsoever. And that's what we do, right? We're developers. So we haven't even done our job. So let's look at, the cost of that. We've got our IT people who are just setting up machines and pushing tickets and opening firewalls, and we're doing all this server management and setup, and neither of us are doing A, what we're really good at, or B, what we really wanted to do, right? I'm not writing code, and IT is not doing wonderful things to protect our systems and configure them and set them up, right? They're busy focusing on stuff just to get me to where I need to be. So what if we could change things so that instead, we each just focused on what we are really good at and like to do, right? So that is where we try something different. And let's say we can just set up a cloud system in the cloud, have some APIs, the users call it. Maybe those APIs can call out to our Acxiom environment, and maybe those APIs can call out to our Atlas database. And maybe that happens really simply because behind the scenes, Atlas and our APIs are all kind of the same thing, right? They're in the same place and they talk to each other. So there's no configuration needed there. And this system is so much simpler because guess what? I didn't even have to call anybody to do this, right? I click a button and this environment comes up and then we start writing code. What does this get us? This gets us server maintenance. We don't have to worry about it anymore, right? The servers are all hosted there in the cloud. We don't have to worry about versioning and all that kind of stuff. Firewall requests, I don't need to put any in because the machines already know how to talk to each other. They are the same thing. Build and deployment infrastructure. I don't have to set up machines, make sure they can talk, make sure they're in the right zones. That's all taken care of. And disaster and recovery planning. These machines already have backups and failovers. They come built in. No longer is that our problem or IT's problem. It's done for us. So that brings us to Stitch. Now, I think you guys, some of you have heard some of the talks, maybe some of you don't know entirely what Stitch is. Stitch is Mongo's backend as a service offering. So that allows you to have this place where you can write functionality to integrate directly with your Atlas and MongoDB. It's got a couple of different areas which we utilize all very heavily in our API that we created. The first of which is their values area. And this is a good place for you to set up things like configuration for your system. Any kind of specific settings that may change from client to client or place to place. It's a good kind of library to look up data. They also have access rules, which they talked a little bit about today and we got to see in some of the keynote stuff. And the access rules make it super simple to configure your access to the data, both within Stitch and MongoDB, to filter down all the way from collection to document to field level security and letting your users only have access to what they are supposed to have access to. Then you have functions. This is kind of your bread and butter of your API, right? This is where you write your code and do what we like to do. And you put all the heavy lifting of your program in. And finally, the webhooks. And this is kind of how we expose our API to the world, right? It allows users to call a URL and kick off some kind of function. And so those are kind of the big main areas of Stitch and how we integrate with it. So here I have an example of how we've utilized values and to map and look up things. So the big thing for us is we have our own authentication system that users are set up in. So we wanted a way to map that to the Stitch user presence, right? So that we knew, hey, this Stitch user and this Acxiom user are the same person, and we can have kind of a whole user view of that person. So here you can see we have the Acxiom user, and it's mapped to their Stitch ID, so that when they log into the system, we can go look that up and know who's doing what. We also have an allowed sources area, and what this does is tell us what of those document types that Scott talked about different users are allowed to have access to. And you can say a specific document type, you can say they have access to all documents, or you can say they have access to no documents. And that's allowed to be configured by user. And the way you utilize that is within the access rules that we talked about. So if you go into the access rule, we have a function that takes that document type and that user ID and looks up in the values and says yes or no. This person can look at this document type or not. And then that's very simple. We don't have to do anything else there. And this is our function that does that. And as you can see, it starts out by looking up in values for that authentication list that we saw. Then it goes through and says, do they have access to all? Okay, good, let them through. Do they have access to none? All right, nope, stop here, you're done. And then it checks for different specific document types. And then we had a fallback because we wanted as a default, as this went out, for users to have access. We wanted this to be more of a intentional blocking than not. So if the user isn't listed there or has nothing listed, then they are allowed to view the document type. And then we have our webhooks. Now we have 3 main webhooks that we have set up, and they all do a little bit different thing. When you configure your webhook, you have a couple of options. The first is whether you have it respond with a result. And you would think, well, maybe I don't, why would you have a webhook that doesn't give you a result? But maybe it's just to kick off like a counter or incrementation or just log something, and you don't really care for a result for that. But all of ours do respond with the results because they're all kind of lookups to the database. You can set them as get and post, and we do a little bit of each. And then, as we talked about, we use that run webhook as and have a script, which is what does that user mapping, and that kind of helps us tie our Acxiom authentication into Stitch's authentication. You can also have that webhook run as a system user, or any kind of script that you would want to put in there. And then we pass our secret as a query parameter on all of our calls. So we kind of have all the different flavors of setting up webhooks in our system. So the first one is sources, and that's kind of our basic hard key lookup that Scott talked about. So we have a user out there, and they have this key from a system, and they want to look up the documents for that user. So they're going to call out to our system, ods.myacxiom.com. And actually the first thing that's going to do is hit our proxy. And our proxy is an AWS Lambda proxy. And it does a couple of things for us. The first is it does some URL rewriting. And mostly because when you set up webhooks in Stitch, they come with a built-in URL. And it's, webhooks.mongodb.com with a bunch of stuff after it. And we wanted to kind of simplify that view to the user. We wanted them to just hit ods.myacxiom.com with their client information and their request, and we would take care of formatting that properly for Stitch for them. So that is the first main job that our proxy does. Secondly, our proxy does some pre-request Json validation. And so when they're making requests or putting data into or out of the system, it goes ahead and validates what they're sending in before it ever hits Stitch. So that helps filter out a lot of bad requests before we've ever even moved on. So if everything goes through the proxy and looks good, that token and key that the user sent in is going to get set to Stitch. And this is where we hit all of our functions and our webhooks and our values and all those things we talked about. And so the first thing Stitch is going to do is take this token that the user's given us. And this is something they've gotten from Acxiom. It's our authentication token. And they've gone out to our API and authenticated with Acxiom system and gotten a token back. We're going to send that token up to Acxiom and say, hey, tell me about this user. Tell me what he's authorized to do, and tell me, the data about him. What client is he with, and is he a valid user in our system? So Acxiom's going to send us back all that user data and say, hey, yep, this user's allowed to use Stitch, and they work with this client. If that's correct, we will forward the request on. Send the key out to Atlas and retrieve the document and send it back to Stitch, who will forward it back to the proxy and send it back to the user. If that user is for some reason maybe not allowed to use the Stitch application or not in the correct client, then that request will get rerouted back out immediately. Our sources by PII is a post lookup of PII data. So the first thing the user's going to do is collect all of his PII data, name, address, email, phone, send that request in to ods.myacxiom.com. We're going to go through the same proxy, and this is where kind of the Json validation becomes more important. Because if it's a bad request, it doesn't have the minimum required data or something like that, we're just going to go ahead and kick back and not forward. So we'll take the token in PII and hit Stitch. Do all of our functioning through our webhooks, call it to Acxiom, make sure that they're allowed to have access to the data that they're trying to access. Send that user data back. And now Stitch is going to take that user data and call out to Acxiom's search system, which is a little bit of what Scott talked about where we come up with that canonical ID. So we'll send that PII back, get a canonical ID, and now we can do the same thing we just did before. Take that ID, go out to Atlas, look up the document, and send it back through the system. And our final webhook is a way for users to feed data back into the system, a feedback mechanism for them. So in this case, the user has some information that they want to eventually make it back out to their data warehouse. So they can put it into the ODS, and then we will have an extract method that runs and feeds the data back into their data warehouse. So the user is going to send their data in. We're going to go back through our proxy, and again, this is another important step for the Json validation in that we want to make sure they're not putting bad data into their system. We'll go through all the same steps of Stitch, sending it out to validate what they do and don't have access to. If they've sent us PII, we will look up the associated key. If we just have a key that they've sent in, then we'll go ahead and feed straight into Atlas. We'll insert the document into Atlas, get back the key, and send the entire document and the new MongoDB ID with the document back to the user. So they now have a clear picture of what they sent in, what got inserted into the document, and the associated Mongo ID with it. One of the things about having Stitch kind of in that middle, on the way in and on the way out, allows us to do a couple of different client customizations. And we do these for both custom validation and for custom exit points in the program. So as the request comes into Stitch, we can have a method in there that's a custom validation just for our user. And if they don't want any custom validations, it can just return true, right? But if they do want some kind of custom validation, they can just write up some JavaScript. We can plug it into the system, and it'll do custom validation for their particular module. Say they don't want any users in the system from New Jersey, right? So they want to reject any records where a user comes in from New Jersey. They can put that in a simple JavaScript, send it to us, we upload it to the system, bam. Their system and their system alone doesn't let customers in from New Jersey. The exit point is similar. We have, a setup and values to let them enable or disable different exit points, and then they can write simple JavaScript that says, hey, we like our dates formatted differently when they come out of the system. So if that's turned on, we'll loop through their custom exit point, do any formatting, or maybe they don't want to see particular data, they don't want that sent out of the system. We'll remove that data before it's returned to them. So that allows us to not actually have to change our code at all, right? They can write some simple JavaScript and have a custom system set up for them. So how did this go for us? Well, our POC, like Scott said, we had me working on the API for a week, and we had Scott who was working on the data load, and we took 1 week, and in that time we had a fully functioning POC that did all of the steps that we needed. In production, we went from July to January, and in that time we had a fully functioning production system with our first production client. And that includes all the things it takes when you're releasing a new piece of software from a company, right? All the approvals, all the security scans, all of those kinds of things. July to January, done. We had a production system up and running from scratch. So what did that get us? We didn't have to worry about disaster recovery, right? That was built in. Backups, they're done, which we've actually had to use. And upgrades, you just click a button and say, I want the newest version, right? Or I want a bigger machine. It's all just built in for you. So what about performance? What does that look like? Well, we did some performance testing early in our development, and our latency was reduced by 1/3. We had 26 million documents that we were querying while we were sending updates to the system, with 35 simultaneous threads running, hitting the system all at once, and we ended up at about 140 transactions per second. Data load, we loaded 17 million records into the database in about 13 minutes, which gives us a rate of 21.4 thousand documents per second upload. And we have put a lot of work into that upload, and those numbers have gone down dramatically even since then. So the performance was great. How scalable is it? Well, again, you log into the system, you click a button, you get a bigger server, you get the newer server. There's very little to almost no downtime. And say you're reaching a limit on the space size and you need to up your server, the alerts are all built in. They tell you when it's time to start upgrading your servers. So this brought us independence, right? We don't have to set up machines anymore, and we don't have to set up firewalls anymore, and we don't have to do any of that deployment and the stuff we were doing. So we're to a point where setting up a client and getting them up on the system takes about 20 minutes.
You guys really picked up IT.
Yeah.
They don't have a login to our system.
No, they cannot exit. And so what does this mean? Well, we don't need all these people, right? Scott and I did a POC in a week, and then we have a team of, 3, yeah. So without all those people, that means you make more money, right? Because you're spending less on developers and machines and all those kinds of things. So it definitely increased profitability, which makes the business side of the house happy, while we've been busy making the developer side of the house happy. One of the things we really like to harp on is the support within MongoDB. It has been extremely responsive. Anytime, we've come into things and had questions and maybe didn't realize how to best do something, all we've had to do is send an email, Slack message, pick up a phone. They have been incredibly responsive, helpful, and reactive on everything we've done. I know building partner relationships with tech companies and dealing with support in other companies is not always easy. And this relationship with Mongo has really stuck out as being an excellent one that we've had to build. I say beta product. Obviously today it's a GA product of a couple of hours, but the experience that we've had the last year, Stitch has actually been in beta, and we've gone to production with Stitch in beta because it's worked out that well. But having it be a newer product, there are a few, hiccups along the way that you look out for. One of those is, if you use the SDK, you've got custom validations and things like that built in. But if you're operating entirely in Stitch with webhooks, there isn't really that custom authentication built in for you. And so our way around that was to do the run webhook as and kind of link up to our Acxiom system. So that was kind of a little bit of a workaround because it's not quite built in for you to be able to just say, hey, here's my authentication module, use this in all of my webhooks. Debugging can be a little bit tricky. It's an online development environment. You don't have like stepping through code and stuff like that. But you've got logging and output and all sorts of different ways. You just have to kind of morph your mind a little bit about how you were going to debug through problems. And Stitch is new. It's a new product, right? And new products make big changes very quickly. And sometimes that means you have to make big changes very quickly as well. So that's just something to be aware of is, they're doing great things. Sometimes that requires you to do some great things really quickly too. Multi-environment management can be kind of tricky. Going from dev to test to production could take a little extra work, right? Because they're all kind of just web-based systems. And so what we've done is Mongo has put out an import-export system for their Stitch where you can export all the pieces of your program and then import it somewhere else. And so we've written some programming around that to make that process almost seamless with about a click of 2 buttons. You can move from a test to a production environment or from client to client. But it's not your typical like build, release, deploy like you would normally do with an application. User management can be a little tricky, and when I say that, I mean mostly users like us developers, because you're going to have like a Mongo account, and you're going to have an Atlas account, and you're going to have a Stitch account, and trying to work through all of those accounts can sometimes boggle the mind a little bit. And then finally, having multiple developers develop in one environment can get tricky, because again, it is a web-based development environment, right? So if Scott and I are both developing in a module and don't know it, last save wins, So that's something you do have to look out for. But with the import-export, you can just export your system, stand up a whole new Stitch, and Scott can go do what he wants wherever he wants. But that's just something you want to look out for if you're in there developing. So where are we now? We have 1 client fully up on production. We have 4 more in implementation. We have 1 code base. We don't have to write any different code for any of the other clients. And so that has really just made us and and our product people really happy. And it's been such a great experience, which is why we're here telling you how simple and fun and easy it's been to be able to just focus on development and dealing with data and the things we actually like to do. So, thank you.
All right, thank you guys for attending. Do we have any time for questions?
So did you put client PII data into Atlas?
We did.
And did you get pushback when you approached the clients?
Not from the clients, but we have a very strong privacy and security practice at Acxiom. So we had already gone through penetration testing, PII review, which is our internal review from all our lawyers and all of that. So surprisingly not. I was kind of waiting on that because most of my ODS experience has been it's got to be over here, can't be out there. When you talk about speed of access, of being out in an AWS or Azure right next to the internet, the benefits far outweigh.
That was my same question.
Yeah.
PII data, did you face any data masking issues? Or?
No, we don't have any need for data masking because we don't have basically Social Security number. We don't have, no, but you can get down to an encryption by field, and with some of the Mongo capabilities, the Atlas is encrypted data store the whole thing, but we haven't had to encrypt any of the specific attributes. Now, remember, we take a subsection of our warehouse and expose it into the ODS, so we don't take everything. Some things we take PII, name and address, to pre-fill applications for offers, so some clients choose, and I showed a common customer structure. If you're going to put name, address, email, and phone out there, here's how to do it. So we standardize that too. It's not required. Keys are required. If you're going to put consumer name, address, put it in this structure, just so that we're standardized. But
Can I just follow up? You said that had a native encryption around that in the storage?
yes, yes. It's using the, I know AWS, it uses AWS's storage encryption. So I think they all use kind of the native, do what? I don't actually know. I haven't gone into exactly how that, we did penetration tests and our security people went through all the reviews, and at the time they had gone through the HIPAA review process and they really had some physical security issues, not around their software, but around their offices and other stuff. The findings were there, not in their software. But as of today, I think they announced that they're HIPAA compliant. So, and they were already SOC 2 Type 1, and SOC 2 Type 2 takes a couple, I think 6 months to a year after you do the Type 1 to see that you're actually doing what you say you're doing over time. You can do Atlas encryption too. Right now we're relying on just the underlying encryption, but you can bring your own keys as of today and do, so they don't even have the key structure.